So in section 3.5, we are going to continue to find exact values of angles that don't have reference angles that are multiples of 30 or 45. In this section, we are going to talk about double angle identities, where we have sine of 2x equals to 2 sine x cos x. Now for cosine of 2x, we can use one of these three: cosine squared minus sine squared x, or 2 cos squared minus 1, or 1 minus 2 sine squared x. Any of these, whichever one is most convenient, we can use to figure out what cosine of 2x is. And tan 2x is 2 tan x divided by 1 minus tan squared x. So for example, if cos squared 39 minus sine squared 39 equals to cosine of a, what is the value of a? Now the first question we're going to ask ourselves is, which pattern does this fit? So cos squared 39 minus sine squared 39 is going to fit this pattern: cos squared x minus sine squared x, and this equals to cosine of 2x. Okay, now let's take a look at the value of x. The value of x in this case is 39 degrees. And so in this parentheses is going to be cosine of 2x, which is going to be cosine of 2 times 39, which is going to be cosine of 78 degrees. So the value of a in this case will be 78. So look for the pattern, figure out the value of x, and in this case these are all double angle identities, which means we're going to multiply x by 2, since cos squared x minus sine squared x equals cosine of 2 times x. So if x is 39, then this parentheses will be 2x, which is going to be 78. Okay, we have if 2 sine 20 degrees times cos 20 degrees equals the sine of a, find the value of a. Let's find out which pattern this fits. So this fits a pattern of 2 sine of x times cosine of x. In this case, x being 20 degrees. So the formula for 2 sine x cos x is sine of 2x. Now remember, in our case, x is 20 degrees. So 2 times x will be the sine of 2 times 20 degrees, which will be the sine of 40 degrees. So a will equal to 40. In letter C, we have 2 times tan 35 degrees divided by 1 minus tan squared 35 degrees. Find tangent of a. So what is the value of a in this case? So once again, it fits this pattern: 2 tan x minus 1 minus tan squared x, and this is going to equal to tan 2x. Now in our case, x is 35 degrees, so we have tangent of 2 times 35, which is going to be tangent of 70 degrees, which means a is equal to 70. So in all these, you're basically looking for the pattern and multiplying the x by 2, since we have a double angle identity. Here's an example. If cos x equals to 4/5 and cosecant of x is less than 0, then we want to find a sine of 2x, cosine of 2x, and tangent of 2x. Now the first thing we have to do is, if cosine of x is equal to 4/5, now even though we have cosecant of x equal to less than 0, I'm going to rewrite that as sine of x, because I think it's always best to write everything in terms of sine, cosine, or tangent. So the reciprocal of cosecant is sine, and we want sine of x to be less than 0. So we want to figure out in which quadrant is cosine positive but sine negative. So the first thing I'm going to do is I'm going to sketch my coordinate plane. I have all students take calculus, and I'm going to start with, where's cosine positive? So cosine's positive in quadrant 1 or quadrant 4. So it can't be 2 or 3, because we want the cosine to be positive. But we want sine to be negative. So out of these two quadrants, we're going to determine where is sine negative, where is sine less than 0. And sine is positive in quadrant 1, which means this angle has to be sketched in quadrant 4. Cosine's positive, sine's negative. So let's sketch this angle x. Okay, we got our reference angle here. So cosine's adjacent over hypotenuse. So this is our adjacent, that's our hypotenuse. And we're looking for the missing side, which we can call y or b or whatever you want to call it. If you apply the Pythagorean theorem, we have a squared plus b squared equals to c squared. So this is 16 plus y squared equals to 25. If we subtract 16 from each side, then we're going to get y squared equals to 9, and then y will be plus or minus 3. Remember, anytime you square root a variable, you always get a plus or minus. And because y is going in the negative direction, y will equal to negative 3. Now, once we have our triangle sketched, let's take a look at each of these. So sine of 2x, the formula for this is equal to 2 sine of x times cosine of x. So what I need to know is what is sine x and what is cos x. So on the side here, I'm going to write that sine of x is equal to opposite over hypotenuse, which is negative 3/5. And cosine of x is adjacent over hypotenuse, which is going to be 4/5. So I just plug this in. This is going to be 2 times sine of x, which is going to be negative 3/5, times cos x, which is 4/5, and put a 1 underneath the 2. I multiply the numerators. 2 times negative 3 is negative 6. Negative 6 times 4 is negative 24. And then 1 times 5 is 5. 5 times 5 is 25. So sine of 2x is equal to negative 24 over 25. So what this is telling us, whatever angle x is, the sine of 2 times that angle will be negative 24/25, whereas the sine of x is negative 3/5. Okay, now let's take a look at cosine. So cosine of 2x. Now we have 3 different formulas we can pick from. We can use cos squared x minus sine squared x, 2 cos squared x minus 1, 1 minus 2 sine squared x. It doesn't matter, we get the same answer either way. So since I already have sine and cosine, I'm just going to say this is equal to cosine squared of x minus sine squared of x. So let's plug this in. Cosine is 4/5, so this is going to be 4 over 5 squared. Sine squared is negative 3/5, so this is going to be negative 3 over 5 squared. According to the order of operations, make sure you guys do the square first. So 4 squared is 16, 5 squared is 25, negative 3 squared is 9, and 5 squared is 25. Notice that these two negatives do not become a positive because the exponent has to be done first. Okay, so do the exponent first, then bring down the negative. 16 minus 9 is 7, so this will be 7 over 25. So we have cosine of 2x is equal to 7 over 25. Lastly, we have to find out what is tangent of 2x. So for tan 2x, the formula is 2 tan x divided by 1 minus tan squared x. So for this, we need to know what is tangent of x. So on the side here, I'm going to write down tangent of x. That's equal to opposite over adjacent. For angle x, that'll be negative 3/4. So let's plug this in. This is going to be 2 times negative 3/4 divided by 1 minus negative 3 over 4 squared. We have to simplify this. So in order to simplify this, this is like saying 2 over 1. So in multiplication, I multiply the numerators. That'll be negative 6, multiply the denominators. But before I can do that, I think it's going to be easier to cross cancel. So 2 goes into 2 once, and it goes into 4 twice. That way we don't have to reduce at the end. So this is 1 over 1 times negative 3 over 2. 1 times negative 3 is negative 3, and 1 times 2 is 2. So the numerator gives you a negative 3/2. Now the denominator, we got 1 minus negative 3/4 squared. Now first off, the two negatives cannot become a positive because remember, order of operations, always do the exponent first. So this is going to give us 1 minus negative 3 squared is 9 and 4 squared is 16. So we get 1 minus 9 over 16. Now we can't have two different denominators. So we have two choices. We can take the 1 minus 9 over 16 and subtract it and then multiply by the reciprocal. Remember, you cannot multiply by the reciprocal until this denominator is written as one fraction. But the easier way is to figure out the LCD. So this is like a 1 over 1. Our three denominators are 2, 1, and 16. So the LCD between 2, 1, and 16 is going to be 16. And what we can do now is we can multiply each of these numerators by 16. So multiply by 16, multiply by 16, and multiply by 16. I think this method is easier as far as simplifying this goes. So now let's simplify. 2 goes into 16 8 times, and negative 3 times 8 is going to be negative 24. On the denominator, we have 16 times 1, which is 16. And then these 16s are going to cross out, so we get 16 minus 9. That's 7. So our answer is going to be negative 24 over 7. Now, this is kind of the longer way of doing this. If you already have sine and cosine, then here's a little shortcut which you can use. But the shortcut you can use only when you have the sine and cosine. So the shortcut is that tangent of 2x is equal to sine of 2x over cos 2x. So we're taking because they have the same denominator, they both have a denominator of 25, we just take the numerator of the y value, which is negative 24, divided by the numerator of the x value, which is going to be 7, and there we go. We get the exact same answer. But you can only use this shortcut when you have sine of 2x and cos 2x. If not, then you have to follow this process, which we did. Here's our next example. We have tangent of x equal to negative 1/3 and cosine of x is equal to 0. So first thing we're going to do is we're going to say, well, we have our coordinate plane and we have all students take calculus. So where is tangent negative? Whenever something's negative, you eliminate the positive quadrants. So it can either be in quadrant 2 or quadrant 4. But then out of these, where is cosine positive? Where is it greater than 0? And it's going to be greater than 0 in quadrant 4, so that's a quadrant we're going to sketch our angle in. It's a reference triangle. This is angle x. We're told that the tangent is opposite over adjacent. It's negative 1/3, so the opposite is going to be negative 1, and the adjacent is going to be positive 3. Notice that because we're going in the negative direction for the y value, it's negative, and we're going in the positive direction for the x value, so the 3 is positive. We want to find out what is the value of c. So if you use the Pythagorean theorem, we have a squared plus b squared equals to c squared. 3 squared is 9, negative 1 squared is 10, equals to c squared. I'm sorry, negative 1 squared is 1, I jumped ahead. 9 plus 1 is 10 equals to c squared. So c is going to be plus or minus radical 10, but because the hypotenuse is positive, then c will just equal to radical 10. All right, now let's take sine of 2x. So first step is to sketch the reference triangle and fill in all the sides. Then we're going to say sine of 2x is equal to 2 sine x cos x. Let's first figure out what is sine of x and what is cosine of x. So sine of x is going to be opposite over hypotenuse, which is going to be negative 1 over radical 10. And if you rationalize that, you would multiply these by radical 10. This will give you negative radical 10 over 10. That's going to be for sine. Cosine of x is going to be opposite over, cosine is adjacent over hypotenuse. That's 3 over radical 10. And if you rationalize that by multiplying by radical 10, this gives you 3 radical 10 over 10. So now we have our sine and we have our cosine. Let's plug this in. So we have 2 times sine of x, so we have 2 times negative radical 10 over 10, times cosine of x, which is going to be 3 times radical 10 over 10, and I'm going to make the 2 into a fraction. So let's multiply the numerators. You have 2 times negative radical 10 times 3 radical 10. A quick reminder of algebra, you can multiply the numbers on the outside. So 2 times 3 is going to be 6, and then you have negative radical 10 times radical 10. that will be radical 100, and the negative goes on the outside, so it's negative 6 radical 100. On the denominator, we have 1 times 10 times 10, which is going to be 100. Now we still have to simplify this. Radical 100 is equal to 10, so this gives you negative 6 times 10 over 100. Negative 6 times 10 is going to be negative 60, and you have negative 60 over 100. If you reduce that, the zeros are going to just cross out. Negative 6 over 10 is going to be negative 3/5 if you divide by 2. So that is going to be my value for sine of 2x. Okay, kind of a long process. Let's do one more. We'll save the tangent for class. Let's do cosine of 2x. So cosine of 2x, remember there are 3 formulas you can use, but since we already have sine and cosine, I'm going to say this is going to be cosine squared of x minus sine squared of x. Okay, so what's cosine? So cosine is 3 radical 10 over 10. But what I'm going to do is, to make my life a little bit easier, I'm going to take the unrationalized form, because if I square something, the radical is going to go away. So to make my life easier, I'm going to actually take the 3 over radical 10, the unsimplified format, to make my life easier. And then sine squared of x, once again, is I'm going to take the negative 1 over radical 10, and then to square that makes things easier. Now 3 squared is 9, and radical 10 squared is 10. Remember that if you have radical x and you square that, it just gives you x. It's one of the properties of square roots. The radical and the square, they undo each other. Always do the exponent first, so the minus sign just comes down. Negative 1 squared is 1, and radical 10 squared is 10. So 9 minus 1 is going to be 8 over 10, and if you reduce that, this will be 4/5. And then the tangent we'll save for class.